Okay guys, this video this week is much shorter. I want to show you a quick estimation kind of thing you might be doing on your worksheets for logs. So notice that I have log base 3 of 10. So they might ask you to estimate this, and you're saying, I'm just going to go to Desmos and type it in, thank you very much. No one's going to stop you. But let's think about what this means. If you rewrite this as an exponential, it would say 3 to what power gives you 10? Well, 3 to the first power is 3. 3 squared is 9. 3 to the third is 27. So you could say 3 to what power approximately would give you 10? It's definitely not between 1 and 2 because that's not even big enough. But from 2 to 3 it is. And it's darn close to 9. So you might pick a different guess and get crazy and super detailed. But I'm going to guess like 3 to the 2.05 power, something like that. So that's my estimate. That's how you would guess what the power might be. Now, could you go ahead and use Desmos? Sure. And type in, so that's my guess right here. Could you go ahead on Desmos and get the exact answer? You sure could. Okay, so go ahead and just type in. Remember, you would use that log base A button. It's when you go to graph and you hit the functions under miscellaneous. But watch this. You could also take your calculator and we can use the change of base formula now. We know that from last week, log base little a of b, or of m, I'm sorry, little b of m we wrote, equals, oh my goodness, sorry, log of m over log of b. All I have to think of is my base is 3, so that goes on the bottom. And my m is 10, so I'd have log of 10. And now, all I have to do is I actually have a calculator with log on it at all times. That's why we love the change of base formula, because if we don't carry Desmos computers around yet, we'd get 2.096. Darn it, I was close, but for guessing, it's not bad. My guess was darn close to the actual value. So I use the change of base here. But I could have used Desmos as well. You have 3 options. All right, one more example here. I have 5 to what power is 12? Now remember, just for fun, to rewrite it as a log, that means my 5 is my base, so I'd have the 5 down here. My 12 was the output of my exponential, so it's my input of my log because they're inverses. And then I'd have x over here. But this is just for fun because it doesn't really help you solve it. Although, could you type that in on Desmos? Oops, sorry, I can't spell it. You could. So we go to Desmos, that would work. We can guess. We know 5 to the first power is 5, and 5 squared is 25. So it's somewhere between 1 and 2. I don't know. I think it's closer. 12 is definitely closer to 5, probably. So my guess, just for now, I'm going to say it's like 1.43. I don't know. What I'm going to do, though, is use my nice logarithm look over here, and I'm going to use my change of base formula. So, how about log, and I kind of get these confused. See how he's in the base here? I put him in the basement of my fraction, if that helps you. There we go. So now I have a calculator right in front of me. That if I take log of 12 divided by log of 5, I don't even have to have that fun base thing, I can write 1.544. Darn it, again, really close, 1.43. Do keep in mind on your calculator, if you type log 12, it like throws up a parenthesis. Please close that parenthesis. You don't want to do 12 divided by 5. You want log of 12 divided by log of 5. Close those parentheses if you're typing on your calculator. All right, happy practicing of your logs.